Welcome. In the last session, we defined the definite integral. There are several properties of the definite integral which mirror the properties of the indefinite integral and of area. Definite integral is linear. You can move constants in and out. Definite integral of f plus g is the definite integral of f plus the definite integral of g. It's also additive over intervals. So definite integral from a to c equals the definite integral from a to b plus the definite integral from b to c if b is in between a and c. There's another very important fact about definite integrals. Remember that Riemann sums came about because you were trying to estimate values of antiderivatives using differential approximations. The question there was, does it really work if you increase the number of subintervals? Now we can be more specific about it. As you let the number of subintervals go to infinity, the Riemann sums can have a limit. If the function is continuous, they will have a limit. And we define the limit to be the definite integral. So the question of whether the process works is whether the definite integral, in fact, calculates values of an antiderivative. The fact that it does, at least for continuous functions, goes by the name of the fundamental theorem of calculus. It connects the two basic processes in calculus, differentiation and integration. So the formal statement is that if f is continuous in the interval from a to b, then if you take the definite integral from a to x of f, that defines a function of x, its derivative is the original function f of x. This is true also at the endpoints if you use one-sided derivatives. So if g is any antiderivative, then it must differ from the integral from a to x of f of t dt by a constant, and this constant must be g of a, or equivalently g of x minus g of a should be same as the integral from a to x of f of x dx. In particular, the integral from a to b of f of x dx should be g of b minus g of a. That is to say, the definite integral calculates the net change in any antiderivative. Of course, if you take any other antiderivative, it will differ by a constant. The net change will just cancel out the constant. This gives us another way of calculating definite integrals. If you can find an antiderivative, you can use this statement to calculate the value of the definite integral. You can calculate definite integrals, you can calculate values of antiderivatives. If you can calculate antiderivatives, you can calculate values of definite integrals. We will talk about situations where definite integrals come about without really talking about antiderivatives. In those cases, if you can find the antiderivative, then you can calculate the definite integral. There are also very efficient numerical techniques to estimate values of definite integrals. Later on, I will show you some of the built-in functions in calculators which encode one very good method, which may not be perfect in all respects, but works well in 99% of the time. So if you want to just estimate the value of a specific definite integral, we can do that as well without really knowing much about calculus, just knowing what definite integrals do. There is yet another way to think about the fundamental theorem. It says that differentiation and integration are inverses of each other. Because this tells you that in one direction, if I integrate first, then differentiate, I get the original function. The reverse is not quite true. If you differentiate first and integrate, you don't get the original function, you just get the net change in the function. So original function and then a constant term. Of course, what the constant term is depends upon where you start your integral. This is the explanation for the name indefinite integral. When we do the indefinite integral, we don't say what a is, where we start the definite integral. Since I don't specify what a is, I don't know what this constant term is. That's the explanation for the plus c. That's the indefinite part of indefinite integrals. That's where the indeterminacy is. So these are the different ways of looking at the fundamental theorem. We will talk about different aspects of it as we go along.